Hello and welcome to Yokateki. Today we are going to make indoor and outdoor temperature logger using Arduino Uno board. I need a temperature logger for an interesting project I'm working on, and I will show you in one of the upcoming videos. It had to be able to measure indoor and outdoor temperature accurately. Also, it needs to be able to measure accurately higher temperatures above 50 degrees Celsius or 120 degrees Fahrenheit. It should be able to log several hours of data, and it should run on battery power. I started searching online for a logger. I live in Dubai, and the only thing I found was professional level accurate loggers, extensively expensive for a small project of this size. I also found cheaper and less accurate USB loggers from China, but the cost of shipping it to Dubai was much higher than the actual cost of the device. Also, at the same time, I remember that I have Arduino Uno board sitting in my drawer. I checked which components I need, and it turned out to be the cheapest option. So I decided to build it myself. In order to achieve this, I needed the following components. All of those can be ordered from the local online store souk.com. Real-time clock DS3231 board, which costed around 35 dirhams, which is equivalent to $9 US. Very accurate temperature sensor DS18B20, both indoor and outdoor version. Each one was 21 dirhams or $6. It is able to measure with half degree accuracy temperatures between -10 and +85 degrees, which is exactly what I was after. SD card adapter that costs 15 dirhams or $4. I already had Arduino, but if you need to buy it online from the same source, it would cost you 29 dirhams or $8. So the total cost for all the parts that you need would be 121 dirham or $33. Temperature sensors will be communicated with Arduino board using one wire system, which means that both of them will need just a power and one wire for the signal. We will connect both sensors to the same digital input D7. Real-time clock communicates using I2C interface, and we will be therefore using two pins, A4 and A5. SD card adapter uses SPI interface, and we will have to use 4 pins, D10, 11, 12 and 13. I will not go into more details in this video on Arduino and communication protocols that are used here, but will explain it in one of the upcoming videos. Let's connect all components using the breadboard and power up Arduino. The most efficient way to create the code is to first test each component separately and make sure Arduino is first able to read the information from the real-time clock, then the temperatures, and at the end to write and read from the SD card. The big advantage of using Arduino board is that you can find lots of libraries online and minimize the code that you need to write. Let's start with the real-time clock. We will use DS3231 library that can be found online. Initially, we have to set the current date and time, which will later be maintained by the internal battery after it is disconnected from the power. We type in the date and time and load it to Arduino. Now let's load the code to test the time readings, and let's see the result from the serial monitor. Now let's add the temperature readings. We will use for this purpose one wire library and read values from both sensors. Let's test the updated code again and check if the readings are accurate. What is left is to test SD card and send the same data that we were seeing on the serial monitor to a text file. We will create text in comma-separated value format so that can be easily imported to Excel. Let's see the result. This is how the text file looks like. Few more details on how I wrote the code. The frequency I needed for this project is once per minute, so I created very simple and effective code. The processor basically reads current time from the real-time clock every second. It compares the reading of the seconds with 00, which means that the new minute has started, and then it reads both temperatures, opens the file on SD card, updates it, and closes the file. Now let's leave the board running for at least 12 hours and check the results. I disconnected the board after 16 hours. The battery was almost fully charged, and it got discharged approximately between 20 and 25%, which means that we could, with this battery fully charged, run the system for several days. This battery has 7,800 milliampere hours. Now let's check the result on the SD card. As both sensors were kept on the desk, both temperature readings should be very similar. It looked great. Let's import it to Excel. Once we have it imported as comma-separated values file, we have all the data we need, and we can use it to create chart or analyze it easily using available Excel tools. There is a potential problem that we need to look into, and that's in case we disconnect the power of the Arduino while it is storing the data to SD card, as the file can end up being damaged and unrepairable. When the temperature is read by the microprocessor, the temperature board LED lights up, and we can see that temperature is being read. As we know that writing to SD card immediately follows reading of temperature, before we disconnect the power, we can wait for this LED to turn on, and then once it is turned off, we can wait for 2 seconds and then disconnect the board from the power, which will ensure that writing was not in progress when we disconnected the power. If you decide to build it yourself, I put all code that I created in one zip file that is sitting in my Dropbox, and the link is in the description. So please feel free to download and ask me if you have any questions or any doubts, or you need any help to make this happen. Thank you for watching Yokateki videos. Please don't forget to subscribe for more interesting videos. Ciao!